This video is about how to solve a system using substitution. So before we begin, I want to make sure that you understand what substitution means. So I want you to think about if you have a substitute teacher. Your teacher's at home and somebody has come in to replace them. Or if we think about a sport, if we need to substitute a new quarterback, the old quarterback comes out and we put a new quarterback in. So when we solve this system using substitution, we're going to take something out and replace it with something else. So here is our first example. We're going to do 2 examples total. What we need to find is we need to find a variable that is all by itself. So this y that says y equals, that is a variable that is all by itself. So what we are going to do is in the other equation where the y is, we're going to take this y out and replace it with this entire expression from the top equation. So the bottom equation, the negative 3x minus 3 is going to stay the same. But where the y is, we're replacing it, or we're substituting that top equation into that spot. Okay, now that's probably the trickiest part of the whole process, is understanding how I substituted the top equation into the bottom equation. But now what we're going to do is we're just going to solve this problem. So we're going to start with the distributive property. So negative 3 times negative 5 is going to be 15x. Negative 3 times negative 17 is a positive 51. Bring the negative 3x in the front down. And then it's still going to equal, it equals 3, not 13. Okay. Now from here, I'm going to combine my like terms. So I'm putting my x's with my x's. Negative 3 plus 15 is going to be 12x. The plus 51 comes down, and it's still going to equal 3. Now I can subtract 51 from each side. Remember, our goal is just to get the x by itself. So we're left with 12x equals negative 48. And then lastly, we are going to divide by 12 on each side. So x equals negative 4. But in a system, it's not enough to know what x equals. We have to know what x equals and what y equals. So what we're going to do is we're going to go back up to the top of our screen and look at our original equations here. And we're going to take one of those original equations. I usually take the top one just because it helps me stay organized. So that top original equation was y equals negative 5x minus 17. But now we know that x equals negative 4 from the work that we did. So what I'm going to do is in this equation, I'm going to replace the x with negative 4. Because that was the answer that we got from our previous work down here. So now I can just calculate what y is going to equal. Well, negative 5 times negative 4 is going to be 20 minus 17. So y is going to equal 3. And lastly, we want to make sure that our solution is written as an ordered pair. X's always come first, so I'm going to put negative 4 and then 3. And my final answer to this system is negative 4, 3. Let's look at just one more example. If you remember from the previous example, what we need to do is we need to find a letter that is all by itself. This time, it's x equals. So in the other equation, I'm going to replace the x, or substitute it. I'm going to take that x out and replace it with the expression from the bottom equation. So the top problem was negative 3. But remember, we're going to take that x out now, and we're going to substitute, or we're going to replace it with the expression from the bottom problem. And then the plus 12y and the 9 stay there. So now we're going to solve this problem. Starting with our distributive property. Negative 3 times 4 is negative 12y. Negative 3 times negative 3 is a positive 9. This plus 12y comes down and it's still going to equal 9. Now I need to combine my like terms. Negative 12 plus 12y is going to make 0y. The 9 is coming down right here, and it's still going to equal 9. Now, something weird happened here. Okay? Usually we don't get 0 y's or 0 x's. When that happens, it's like that letter's not even there anymore. Like you can just scribble it out. Because if I have 0 y's, I don't have any of them. I'm not even going to write it down. So our variable completely canceled out, and all we are left with is the number 9 equals the number 9. Now we have two options here. Our answer is either going to be no solution, or it's going to be infinite solution. Well, when I look at these two numbers, since they're the same, 9 does in fact equal 9. That means that my final answer is going to be infinite solutions. And we would just write infinite solutions, and then we would be done. However, let's say in another problem, our y's cancel out just like in this problem, but instead of 9 equals 9 at the end, we are left with something like 8 equals 9. Well, 8 does not equal 9, so if this were the case, instead of writing infinite solutions, we would write no solution. But in this problem, our numbers were the same, so our final answer was infinite solutions.